Hello guys, this is Lisa from Daily Life Engineering. Today I will discuss about balancing. Balancing in anywhere balancing is two types. Balancing of rotating masses and balancing of reciprocating masses. Let us know what is balancing. When a shaft rotates, it vibrates because of out of balance inertia force. The higher the unbalanced inertia force, the more is the chance of shaft failure. So all rotating shaft must be balanced to minimize vibration and noise. So balancing of rotating mass. Let us know what is balancing of rotating masses. The process of providing the second mass in order to counteract the effect of the centrifugal force of the first mass is called balancing of rotating masses. It has two classification. One is all masses in the same plane, and the other one is all masses are in the different plane. All masses in the same plane have two criteria: balancing of a single rotating mass by a single mass rotating in the same plane, and the second criteria is balancing of different mass rotating in the same plane. Now we will know the all mass are in the different planes criteria. First one, balancing of a single rotating mass by two masses rotating in different planes, and the second criteria is balancing of different masses rotating in the different planes. So if we consider the first criteria of all masses in the same plane, balancing of a single rotating mass by a single mass rotating in the same plane. So if we consider M1 in balancing in a plane, and M2 is added just to balance its centrifugal force of the M1 masses that creates just for the M1 masses. So here I have shown the position of masses in the plane, and here is the angular position of the masses. I have considered omega is the angular velocity of this system. Okay. Let's know, in this case, only force balance is required as masses are in same plane. So centrifugal force exerted by mass M1 on the shaft is, I have considered centrifugal force as Fc1, so which is equal to M1 omega square R1, which is equation 1. And for M2 masses, Fc2 equals to M2 omega square R2. If we equate the two equation, then Fc1 is equal. It should be the equal of Fc2, just because we need a balanced situation. So if this situation if we want to be this situation to be balanced, then Fc1 is just should be the equal of Fc2. That's why we are putting M1 omega square R1 is equal to M2 omega square R2. Omega square is same for this two factor, so we are we are taking it as common. So M1 R1 equals to M2 R2. So we are seeing that this balancing criteria is depend on these factors. If we are balancing one mass which is in the same plane, and taking another mass just to balance it on the same plane, then these are the criteria. Now we will see the various masses in the same plane. We will consider that. So let's consider mass M1 is acting here, and here is this all this mass is acting on the same plane on different plane. Like here M1 is acting one here. For M1, the centrifugal force is Fc1, and for M2, the centrifugal force is Fc2, and for M3, the centrifugal force is Fc3. So we are considering a reference axis. From here, we will define the angular displacement of this force line, I think, and this is the resultant force line, I mean, which we will add a mass, and by adding this mass I will balance all this rotating mass. Okay. Let's draw a vector diagram, which is this one. is the resultant value, and this will balance all this force. And if we consider a balance situation, then we have to think that all the forces summation is 0. Then we are taking force summation is 0. Then we know F equals to ma, then we are taking it. But here is the here we saw that there is angular velocity and angular displacement. That's why we are replacing a by r omega square, and omega is constant, which can't be 0. So we can write that the moment of each mass, the moment for the mass is MIRI equals to 0. So let's take revolving mass are at different plane. So we are taking this M1, M2, M3, M4. So here is the reference line. So the length of M1 is L1 from the reference line. The length of M3 from the reference line is L3. So the length of M2 from the reference line is L2, and the length of M4 from the reference line is L4. Here I have shown the position of planes of the masses. So let's see the angular position of the masses. So the angle between M1 and M2 is considered as theta 1, and the angle between M2 and M3 is considered as theta 2, and the between M3 and M4 is theta 3, and M4 and M1 is theta 4. So if we consider balanced position for revolving masses at different plane, then all forces summation must be 0. So the moment of the force is M1 R1. So but here we can see that for different distance from reference plane, couple of the force must be balanced. So the different for the different length couple is created. That's why the couple must be balanced. If the couple is not balanced, then the proper balancing will not be done. So we are multiplying the length with the force, and here again we know force equals to F equal to ma. Then we are doing this calculation. At last we can see that MIRI into LI equals to 0. So here is the equation for revolving masses as different plane which create couple. That's all for today. Thank you guys. If you have any question, you can write it in the comment section, and if you like my video, please subscribe my channel, and if you like my video, then press the like icon. Thank you and have a nice day.